So today on this video, we're going to practice multi-step factoring. So when I was talking about factoring the other day, or teaching factoring the other day, I said these are the steps we always want to use. We want to first always look for a greatest common factor, and then we factor the trinomial. The way we're going to factor a trinomial is by the tic-tac-toe method. So if you tried to tic-tac-toe this one, for example, you have 20 as your first or your leading coefficient. 20 is not prime. You have multiple options that you could use for factors. So 10 and 2, 5 and 4, 1 and 20. Same thing for 24. When you're trying to find factors of 24, you could use 1 and 24, 8 and 3, 6 and 4. So each of these have 3 sets of factors, and it might take you a really long time to try and factor. In addition to that, you always should factor a greatest common factor anyways. So again, we always want to first look for a greatest common factor, and then we can focus on tic-tac-toe. So if I'm looking at number 10, for example, we're going to first look for a greatest common factor. So I'm trying to find what is the largest number that I can divide out of 20, 52, and 24. So hopefully you know your math facts and you're able to do this. So we have 20. So I would look for factors of 20. Well, 1 and 20. So 20 doesn't divide into 52, so that's not going to work. 10 doesn't divide into 52, that doesn't work. 5 doesn't divide into 52, so that doesn't work. So then we have 4, and you might not know this, but 52 divided by 4 is actually 13. So that does work, and 24 divided by 4 also works. So 4 is the greatest common factor. So we're going to divide each of these terms by that greatest common factor. So we're dividing by 4 for each of these. So we're going to take that 4 out. We're dividing the 4 out. That goes on the outside of the parentheses. And then in parentheses, we put what's remaining after we've divided. So 20 divided by 4 is 5. And then we still have n squared. Minus 52 divided by 4 is 13. And we still have n. Minus 24 divided by 4 is 6. So now we've factored out a 4, and we are left with this trinomial, which is going to be a lot easier to factor by tic-tac-toe than this one would have been. So we're going to now tic-tac-toe this trinomial, and we're going to get the 2 binomials. So I already know my answer is going to have 4 in the front. Then I'm going to have 2 binomials. So I usually will go ahead and write this out. The most common mistake I see is students forget that they factored out this 4, and so then they write an answer with just the 2 binomials and not the 4. So if you go ahead and write the 4, then you don't forget it. Okay, so then we're going to draw our tic-tac-toe grid. I kind of spoiled you because on the last few notes we've had the tic-tac-toe grids. Know that on your EOC, you're obviously not going to have that. You're going to have to draw it yourself. So our tic-tac-toe grid is 2 vertical lines with 3 horizontal lines. Okay, so we are going to fill in our tic-tac-toe grid now. So the 5n squared always goes in the top left. That's the first term. So 5n squared in the top left. Then the negative 13n, the middle term, always goes in the bottom right. So negative 13n down here. And then negative 6, the constant term, always in the top middle. So 5 is prime. That's nice because we only have one option. The only way to get 5 is 5 times 1. And n squared, we use n and n. So we're going to do 5n and 1n is the only option there. For 6, we have a couple of different options. We could try 6 times 1 or 3 times 2. Again, we're trying to get to 13 over here. So many of my students have said, oh, well, 5 times 3 is 15, and that gets us close to 13. And that's true. So that's a really good observation. If you recognize, well, 5 times 3 is going to be 15, well, that's getting us really close. So let's try that. So if I put 3 here and 2 here, now multiply across. So 5 times 3 is 15, and 1 times 2 is 2. So now the question is there a way to get 13 out of 15 and 2? Again, in this column, we are adding or subtracting. And there is. To get 13, you actually need to subtract these, but the larger one needs to be negative to keep a negative. So the 15 is going to be the negative here. So negative 15 plus 2 would actually get you negative 13. If I put a negative on this 15, I have to carry that negative over here to the 3. And remember, we always go back and we check this middle column one more time. Is now 2 times -3, -6, and it is. So there are our factors, or our two binomials. So we're going to use 5n plus 2, and then 1n minus 3, or just n minus 3. So this would be our completely factored answer. All right, so let's look at another one. Number 11. So again, we're looking for first, always first, we want to look for a greatest common factor. So we're looking for a greatest common factor for 10, 75, and 35. And hopefully you know that that would then be 5. 10 doesn't work. The only other factor of 10 would be 5 and 2. 2 doesn't work. 5 would definitely work. 5 is also larger than 2, so we would try that first. So we're going to factor out 5. So the 5 goes in the front, and then parentheses, we put what's left over inside those. So 10 divided by 5 is going to be 2. We still have that k squared, plus 75 divided by 5 is 15, and we still have k, plus 35 divided by 5 is 7. So now at this point, we're going to factor this trinomial, and we factor our trinomial for us, we're going to use the tic-tac-toe method. So we're going to draw our tic-tac-toe grid. And then we'll fill in our trinomial. So we have 2k squared in the top left, 15k, that's the middle term, always in the bottom right, 7 in the top middle. Both of these are prime, so this actually works out in our favor. We just have to figure out where do we put the 2 and where do we put the 7. So 2k squared, the only way we can get that is 2k times 1k. 7, the only way we can get that is 1 times 7 or 7 times 1. We're trying to get to 15, so think about where would you want to put that 7. Well, if I put 7 across or next to the 2, then I'm going to get 14. So that gets me pretty close to 15. So let's do that. So we're going to put 7 in the top one and 1 in the bottom one. Multiply across, 2k times 7 is 14k. 1k times 1 is 1k. And the way we can get 15 out of 14 and 1 is if we just add. This one had all positive signs, so nothing should change, and these are definitely the easier of the trinomials that you're factoring. So our factors are 2k plus 1, 1k plus 7. And notice I forgot to bring down my 5 after I just said, make sure you do that. So bring down your 5, parentheses, 2k plus 1 is our first factor, times 1k plus 7, or just k plus 7. So that is going to be our final answer there. Okay, so one more. We'll look at number 12. So we're looking for a greatest common factor between 12, 2, and 2. Well, 2 it has to be, because the only number I can divide out of 2 is 2, and 12 is divisible by 2. So we're going to divide 2 out of each of these terms. 2 goes on the outside. Inside our parentheses, we're going to leave what's left over. So 12 divided by 2 is 6x squared, plus 2x divided by 2 is going to be just x. 2 divided by 2 is 1. Minus, again, 2 divided by 2 is 1. From there, now we're going to factor our trinomial. I'm going to go ahead this time. I'm going to remember to bring down my 2, and then I'm going to have 2 binomials from factoring this trinomial. The way we factor a trinomial is we use the tic-tac-toe method. So we're going to draw our tic-tac-toe grid. And we'll fill in our pieces. So we have 6x squared as our first term in the top left, x in the bottom right, that's our middle term, and -1 in the top middle. This time I'm going to start with the middle column, the 1, because that's prime. The only option is 1 times 1. I don't have any other option. We'll come back and look at the negative in just a minute. So if I start here, because I know that's the only option, then that might make this a little bit easier. So factors of 6, I could use 6 times 1 or 3 times 2. Well, I know over here I'm trying to get 1, and since both of these are 1, I need these numbers to only be 1 apart, and so 3 and 2 are the only ones that are going to work here. So we're going to do 3x and 2x. Multiply across, 3x times 1 is 3x. 2x times 1 is 2x. So we're trying to figure out how do I get x, or 1x, out of 3 and 2? Well, you get that if you subtract the 2. So if I make this 2 negative, I carry that over to the middle. Check this middle column. Is now negative 1 times 1 negative 1? And it is. So our factors are 3x minus 1 and 2x plus 1. So there are a few examples of when we have to factor out a greatest common factor first and then factor by tic-tac-toe.